Guten Tag, Herr Engel.
The
Was ist das
HATS
für ein Motor?
E85G is a robust diesel engine designed for industrial and
Wie viel
commercial
PS?
applications, known for its reliability, efficiency, and durability. It is a 3-cylinder, liquid-cooled engine that delivers consistent power in a compact design, making it ideal for construction equipment, generators, agricultural machinery, and material handling systems. With a displacement of approximately 1.8 liters, the E85G offers fuel-efficient performance while maintaining high torque at low RPMs, ensuring smooth operation under heavy loads.
Gib mal Gas.
Engineered with precision, the HATS E85G features advanced fuel injection technology and low-emission combustion, complying with stringent environmental standards. Its straightforward design reduces maintenance needs and ensures long service intervals, which is particularly valuable in demanding industrial settings. Known for its quiet operation and vibration-resistant construction, the E85G provides both operator comfort and long-term reliability. Overall, it is a versatile diesel engine that balances power, efficiency, and durability in a compact package.
Vielen Dank, Herr Engel.
The Campbell KL110 evaporator motor is a robust stationary diesel engine designed for industrial and agricultural applications. Known for its durability and reliable performance, this engine powers evaporator systems efficiently, ensuring consistent operation under demanding conditions. Its stationary design makes it ideal for fixed installations, where continuous or long-duration operation is required. The diesel-powered engine offers excellent fuel efficiency and torque, making it suitable for heavy-duty tasks. Built with precision engineering, the KL110 combines longevity with low maintenance needs, providing a dependable solution for industries that require stable and powerful mechanical drive for evaporators or other stationary machinery. The setup in this video is a fascinating blend of old-school engineering and sweet rewards. At the heart of it is a Volvo Penta MD1, a compact single-cylinder marine diesel engine. Originally designed to power small boats, the MD1 is rugged, simple, and dependable, perfect for steady, low RPM work. Here, it's been repurposed to drive a country freezer ice cream maker, a traditional hand-crank-style freezer adapted to run by pulley and belt. The diesel's output shaft spins up to about 100 RPM, which, with the pulley ratios, translates to the freezer turning at around 30 to 60 RPM, the sweet spot for churning ice cream. This range is slow enough to freeze smoothly while incorporating just the right amount of air. Pairing a marine diesel with an ice cream freezer may seem unusual, but it highlights ingenuity, combining reliable mechanical power with the timeless pleasure of homemade ice cream. The Flathead Racing Engine 48 is a classic symbol of post-war American motorsport. Built on the Ford Flathead V8 design, it became a favorite among hot rodders and racers for its simplicity, reliability, and tuning potential. By 1948, racers had mastered modifications such as high compression heads, dual carburetors, and custom exhausts, unlocking impressive performance from the compact engine. Its distinctive flat-cylinder head layout gave it the nickname Flathead, and its unique sound became iconic on dirt tracks and drag strips. Today, the Flathead Racing Engine 48 stands as a legend in automotive history, celebrated for fueling grassroots racing culture. The 1929 Graham Page Racer, with its straight 8-cylinder engine, was a bold statement of performance and innovation in the late 1920s. Graham Page, already known for stylish and well-engineered cars, introduced this model to showcase speed, smoothness, and refined engineering. The straight 8 layout delivered impressive power and torque, offering a smoother ride than many contemporaries. Built with a low-slung, sporty profile, it embodied the era's fascination with speed and modern design. While not as common as some luxury rivals, the Graham Page Racer remains a significant example of American ingenuity, blending engineering excellence with elegant styling in the pre-Depression automotive world. The Perkins P6 was a 6-cylinder diesel engine introduced in the late 1930s by F. Perkins Limited of Peterborough, England. Designed as a larger counterpart to the company's successful 4-cylinder P4, the P6 was built to meet the growing demand for durable, fuel-efficient power units in trucks, buses, agricultural machinery, and industrial applications. It quickly earned a reputation for reliability and steady performance, making it a popular choice for medium-duty vehicles and stationary equipment. The P6 displaced 4.7 liters and featured an inline configuration with direct injection, which was advanced for its time. Like other Perkins engines, it emphasized fuel economy and long service life, appealing strongly to operators during an era when efficiency and low running costs were vital. The engine was also relatively easy to maintain, further enhancing its appeal in both domestic and export markets. During its production life, the P6 powered a wide variety of vehicles, including British lorries, delivery vans, and buses, as well as agricultural tractors and combines. Its success helped cement Perkins' reputation as a leading manufacturer of diesel engines. Though later superseded by more modern designs, the Perkins P6 remains a respected milestone in the history of British engineering. The Detroit Diesel 6-71 TIB is a legendary 2-stroke inline-6 marine diesel engine, widely respected for its durability and performance. Part of the iconic Detroit Diesel 71 series, the 6-71 designation refers to 6 cylinders with 71 cubic inches of displacement each, totaling 426 cubic inches. The TIB version, turbocharged, intercooled, bypass, delivers higher horsepower and torque, making it popular in sport fishing boats, workboats, and military applications. Known for its distinctive sound and rugged reliability, the 6-71 TIB offers excellent power-to-weight ratio and ease of service. Though older by today's standards, it remains a classic workhorse in marine propulsion. The MAN D2842LE406 is a robust 5th 12 marine diesel engine designed for demanding commercial and workboat applications. Delivering a power output of around 100 kilowatts, 500 horsepower, at 100 revolutions per minute, it combines high performance with proven reliability. Its 21.9-liter displacement, turbocharging, and charge air cooling ensure efficient combustion, strong acceleration, and consistent power delivery, even under heavy loads. Built with a compact design, it offers space-saving installation options, making it suitable for vessels where space is limited. The engine is known for its durability, low fuel consumption, and compliance with international emission standards. With advanced fuel injection technology and optimized cooling systems, the MAN D2842LE406 provides operators with reduced operating costs and long service life, making it a trusted choice in the marine industry. The Detroit Diesel Series 16V92 is a powerful two-stroke diesel engine, part of the well-known Detroit Diesel 92 series family. Introduced in the late 1970s and widely used through the 1980s and 1990s, this engine earned a reputation for durability, reliability, and strong performance in heavy-duty applications. The 16V designation refers to its V16 configuration, while 92 indicates the cubic inch displacement per cylinder, resulting in a massive total displacement of nearly 24 liters. The 16V92 was engineered to deliver high horsepower and torque, making it ideal for demanding uses such as buses, trucks, construction machinery, power generation, and marine propulsion. Depending on its configuration and turbocharging or supercharging options, it could produce anywhere from 600 to over 400 horsepower. Its robust design allowed continuous operation under extreme loads, a key reason it became popular in military and industrial sectors as well. Like other Detroit diesel two-stroke engines, the 16V92 was appreciated for its simplicity of maintenance and widespread availability of parts. However, it was also known for high fuel consumption and emissions, which eventually limited its use as stricter environmental standards emerged. Today, the Series 16V92 remains a legendary engine, admired by enthusiasts and still in service in select heavy-duty and marine applications. The Western Antique Power Associates, WAPA, proudly runs their restored Western 200 horsepower engine, a massive piece of early industrial history. Built to power factories, mills, or pumping stations, this giant engine represents the ingenuity of the early 20th century. WAPA volunteers carefully maintain and operate it, demonstrating the scale and power of vintage machinery. When fired up, the 200 horsepower engine comes to life with rhythmic motion, drawing crowds who marvel at its engineering and endurance. The demonstration is not only about running an old engine, it's about preserving heritage, showing how mechanical power once drove progress before electricity became widespread. WAPA's dedication keeps the Western 200 horsepower engine alive as a living artifact, inspiring future generations to appreciate history, craftsmanship, and the machines that shaped modern industry. The 1937 John Deere Model D tractor was powered by one of the most iconic engines in early American farm machinery. At its heart was a massive two-cylinder, horizontally opposed engine that displaced 501 cubic inches. Known for its slow, powerful putt-putt exhaust note, this engine epitomized the John Deere two-cylinder design that farmers came to associate with rugged reliability and torque. The 1937 version of the Model D engine featured improvements in cooling, lubrication, and efficiency compared to earlier models. Producing around 38 horsepower at the drawbar and 43 on the belt, it was built to handle heavy tillage, threshing, and other demanding farm tasks. With a low operating speed of around 975 RPM, the engine delivered exceptional pulling power rather than high speed, making it ideal for draft work in tough soil conditions. Fuel flexibility was another advantage. Many tractors of this era, including the D, were designed to start on gasoline and then switch to cheaper fuels like kerosene or distillate once warmed up. Combined with its simple magneto-ignition system and durable construction, the 1937 John Deere D engine earned a reputation for longevity. Even today, collectors prize the tractor's unmistakable sound and enduring mechanical strength. Gardner's first start in the 6L3 marked a significant moment in his development as a player, giving him the opportunity to prove himself on a bigger stage. Leading into the game, there had been curiosity about how he would handle the pressure, as the 6L3 competition is known for testing both skill and composure. From the opening minutes, Gardner showed confidence, settling quickly into his role and demonstrating why he had earned the chance to start. His movement off the ball was intelligent, allowing him to create space and link up effectively with teammates. Defensively, he stayed disciplined, tracking assignments and stepping in at the right times to disrupt plays. While there were moments of inexperience, hesitant decisions, or rushed passes, these were outweighed by flashes of real potential. Gardner's energy and work rate stood out, as he consistently pushed the tempo and looked to make an impact in transition. Though the final result of the match was not solely defined by his performance, Gardner's debut start in the 6L3 gave fans and coaches a glimpse of what he could bring in the future. It was a solid foundation, suggesting that with more minutes and experience, he could grow into a reliable and influential figure.
Fantastico!
The Detroit Diesel 4-53T is part of the rugged and reliable 53 Series two-stroke engine family, well known for powering industrial, marine, and off-highway applications. The designation 4-53T identifies it as a four-cylinder 53 cubic inch per cylinder engine with turbocharging, giving a total displacement of 212 cubic inches. Like all Detroit two-strokes, it features Uniflow scavenging with blower assistance, mechanical unit injectors, and a simple, durable design that has earned it a reputation for longevity in harsh environments. When fitted with 9B90 injectors, the engine's fuel delivery is significantly increased compared to stock configurations. The injector code indicates both size and spray pattern, with the 90 often referring to the injector's capacity rating. This upgrade allows the 4-53T to deliver more fuel per stroke, which, when paired with the turbocharger, produces a noticeable rise in horsepower and torque. In practice, this setup can push the engine into the 160 to 180 horsepower range, depending on tuning, exhaust setup, and cooling efficiency. The turbocharger not only boosts power, but also improves combustion efficiency, reducing the characteristic smoke output of naturally aspirated two-stroke Detroits. While the 4-53T with 9B90 injectors is far from a quiet or fuel-conservative engine, it delivers strong low-end torque and a quick throttle response, making it a favorite in light trucks, equipment repowers, and even performance builds. Operators value the engine's mechanical simplicity, ease of maintenance, and the unmistakable Detroit screaming Jimmy sound. Combined with the injector upgrade, it becomes a compact powerhouse with impressive pulling ability. The E-Walker Solothurn automatic lathe from Switzerland is a precision machine tool specifically designed for efficient screw production. Built with Swiss engineering expertise, it delivers accuracy, reliability, and high repeatability, making it suitable for large-scale manufacturing environments. This automatic lathe is equipped to handle continuous operations with minimal manual intervention, reducing labor costs while ensuring consistent product quality. Its design emphasizes durability and smooth operation, allowing manufacturers to produce screws and other threaded components with tight tolerances. E-Walker Solothurn machines are well regarded in the field of precision engineering, often chosen by industries that require dependable mass production of small metal parts. By integrating automation with precision turning technology, this lathe remains a valuable solution for screw manufacturing in both historical and modern contexts. The Deutz MAH 914 single wheel from 1958 is a distinctive agricultural machine that reflects post-war Germany's ingenuity in designing versatile, compact tractors for small farms. Unlike conventional four-wheel tractors, the MAH 914 was a single-axle walk-behind tractor, often referred to as a motor plow or Einachser in German. Its design focused on affordability, maneuverability, and adaptability, making it a popular choice for farmers with limited acreage or hilly terrain where larger machines were impractical. Powered by a Deutz air-cooled diesel engine, the MAH 914 delivered robust performance with minimal maintenance needs. The engine's reliability and efficiency were key selling points, as Deutz had already established itself as a pioneer in air-cooled diesel technology. Farmers could use the machine for a wide variety of tasks, including plowing, mowing, hauling, and cultivating by attaching different implements. Its single-wheel configuration provided excellent maneuverability, allowing farmers to work in tight spaces such as vineyards, orchards, and small plots. The MAH 914 also emphasized durability, with a solid build that could withstand intensive daily use. Today, surviving examples are sought after by vintage tractor enthusiasts and collectors, both for their unusual design and as a reminder of the transitional era in agricultural mechanization during the 1950s. The diesel generator 1KVD8SL is a robust and reliable power generation unit designed to provide efficient electricity supply in industrial, commercial, and backup applications. Built with advanced engineering, this generator combines durability with high performance, making it suitable for continuous as well as standby operations. Equipped with an 8-cylinder diesel engine, the 1KVD8SL delivers consistent output while maintaining fuel efficiency. Its sturdy design ensures reliable operation under varying loads and environmental conditions. The cooling and lubrication systems are engineered to prevent overheating and reduce wear, thereby extending the service life of the engine. One of the key advantages of this generator is its fuel economy, which helps minimize operational costs. The diesel engine is designed to consume fuel efficiently while maintaining stable voltage and frequency. This makes it suitable for sensitive equipment that requires a steady power supply. The 1KVD8SL is also valued for its low maintenance requirements. Routine servicing is simplified by accessible components, ensuring minimal downtime. Its noise and vibration levels are kept within acceptable limits, allowing installation in different settings without significant disturbance. The Škoda 1S110 was a compact single-cylinder stationary engine produced by the renowned Czechoslovak manufacturer Škoda. Designed for reliability and durability, it was widely employed in agriculture, workshops, and small-scale industrial applications, where a simple yet robust power source was required. At the heart of the 1S110 was a one-cylinder engine with a cylinder capacity of 1,425 cc. Despite its relatively modest displacement, it delivered 15 horsepower at 500 revolutions per minute, a performance well-suited to driving pumps, mills, compressors, and generators. Its operating weight of 470 kilograms reflected its heavy-duty cast-iron construction, ensuring long life under continuous use and providing stability when mounted in stationary installations. The 1S110 represented Škoda's commitment to accessible engineering solutions during a time when many rural and industrial users relied on independent power generation. Its simplicity made it easy to maintain, with straightforward access to the cylinder, piston, and fuel system. Thanks to its low-speed operation and solid build, it was known for reliability and steady output, even under less than ideal working conditions. Although production has long since ceased, engines like the Škoda 1S 110 remain of interest to collectors and enthusiasts of historic machinery. They embody the engineering philosophy of mid-20th century Czechoslovakia. Practical, durable, and built to serve reliably for decades. The Slavia D8 engine is a small stationary diesel engine produced by the historic Slavia company in Napojedla, Czechoslovakia. Known for its simplicity, reliability, and durability, the D8 was widely used in agriculture, light industry, and rural settings during the mid-20th century. With a power output of around 8 horsepower, the engine was strong enough to operate machinery such as water pumps, threshers, mills, saws, and small generators, yet compact and efficient enough to be handled in modest workshops or farms. The D8 belongs to the broader Slavia tradition of single-cylinder engines, which became popular across Europe due to their robust cast-iron construction and long service life. It was typically water-cooled, with a slow-running design that emphasized fuel efficiency and reduced wear on moving parts. Farmers appreciated its ability to run for long hours under demanding conditions with minimal maintenance. Starting was usually achieved with a hand crank, a method that required some skill but reflected the engine's mechanical straightforwardness. Engines like the Slavia D8 played an important role in mechanizing rural economies before widespread electrification. They provided affordable power in places where electricity was unavailable or unreliable, making them indispensable to local communities. Today, the Slavia D8 is considered a classic vintage engine, valued by collectors and enthusiasts who restore and display it at historical machinery shows. It stands as a testament to practical engineering and the industrial heritage of Central Europe. The Slavia 2S95A2 is a robust single-cylinder diesel engine, widely recognized for its reliability and efficiency in agricultural, industrial, and stationary power applications. Built with durability in mind, this engine is engineered to perform consistently under demanding operating conditions, making it a trusted choice for farmers, small-scale industries, and rural power generation needs. The 2S95A2 engine typically features a direct injection fuel system, which ensures efficient combustion and better fuel economy compared to older indirect injection designs. With a bore of 95 mm, it is optimized for medium-duty performance while maintaining low fuel consumption. The engine operates on diesel fuel and is designed to deliver dependable output at steady speeds, suitable for powering irrigation pumps, flour mills, small generators, and other equipment requiring continuous operation. Its air cooling system eliminates the need for complex radiators, simplifying maintenance and making it highly practical in remote locations with limited resources. Additionally, the engine's rugged construction, including heavy-duty bearings and sturdy cast-iron components, enhances longevity and resistance to wear. The Slavia 2S95A2 is also valued for its ease of servicing. Spare parts are generally affordable and widely available, which adds to its popularity in regions where cost-effectiveness is essential. The Slavia 27 HP was a robust internal combustion engine produced in the early 20th century by the renowned Czech manufacturer Slavia, a company well known for its stationary and agricultural engines. With a rated output of 27 horsepower, this engine was designed primarily for heavy-duty applications such as powering threshing machines, sawmills, irrigation pumps, and other agricultural or industrial machinery. It represented the technological shift from steam power to more compact, efficient oil and gasoline engines. The Slavia 27 HP typically featured a large, single-cylinder, four-stroke design with a horizontal orientation, which was common for stationary engines of its time. Its massive flywheels provided the necessary inertia to maintain steady operation under load, while the slow-running nature of the engine made it reliable, durable, and capable of working for long hours with minimal wear. Fuel efficiency and relatively simple maintenance were additional advantages, which made it a popular choice in rural areas where robust performance and reliability were essential. Built with heavy cast iron components and precision engineering, the Slavia 27 HP combined durability with practicality. Today, surviving examples of these engines are preserved and exhibited at vintage machinery shows and museums, admired for their engineering heritage and distinctive rhythmic exhaust note. The Slavia 27 HP stands as a testament to early European industrial innovation and the crucial role of stationary engines in mechanizing agriculture and industry. The Slavia 27 HP was a robust internal combustion engine produced in the early 20th century by the renowned Czech manufacturer Slavia, a company well known for its stationary and agricultural engines. With a rated output of 27 horsepower, this engine was designed primarily for heavy-duty applications such as powering threshing machines, sawmills, irrigation pumps, and other agricultural or industrial machinery. It represented the technological shift from steam power to more compact, efficient oil and gasoline engines. The Slavia 27 HP typically featured a large, single-cylinder, four-stroke design with a horizontal orientation, which was common for stationary engines of its time. Its massive flywheels provided the necessary inertia to maintain steady operation under load, while the slow-running nature of the engine made it reliable, durable, and capable of working for long hours with minimal wear. Fuel efficiency and relatively simple maintenance were additional advantages, which made it a popular choice in rural areas where robust performance and reliability were essential. Built with heavy cast iron components and precision engineering, the Slavia 27 HP combined durability with practicality. Today, surviving examples of these engines are preserved and exhibited at vintage machinery shows and museums, admired for their engineering heritage and distinctive rhythmic exhaust note. The Slavia 27 HP stands as a testament to early European industrial innovation and the crucial role of stationary engines in mechanizing agriculture and industry. The Regan vapor engine was an innovative hot air engine developed in the late 19th century, designed to serve as an economical and practical alternative to steam power. Invented by J.C. Hoadley and licensed to the Regan Vapor Engine Company of San Francisco, this machine used a volatile hydrocarbon fuel, often gasoline or similar light oils, to create vapor that expanded and drove a piston. Unlike traditional steam engines, it did not require large boilers or extensive heating, making it compact, safer, and more efficient for small-scale operations. The working principle of the Regan vapor engine was based on the controlled vaporization of fuel within a heated chamber. The resulting vapor was admitted into the cylinder, where it expanded and performed useful work. After expansion, it was exhausted and recondensed, allowing a portion of the vapor to be reused. This method reduced fuel consumption while avoiding the dangers of high-pressure steam boilers. The Regan vapor engine found applications in printing presses, sewing machines, light industrial machinery, and small workshops, where moderate power was required without the expense or bulk of a steam plant. Its reliability and ease of operation made it popular during the transitional period between steam and internal combustion engines. Although eventually overshadowed by gasoline and electric motors, the Regan vapor engine remains an important milestone in the history of mechanical power development. The Diebold Tractor Show Log Splitter is a popular attraction that highlights both heritage and hands-on innovation. Known for celebrating rural craftsmanship and machinery, the event showcases vintage tractors alongside modern equipment, with the log splitter drawing special attention. This powerful machine demonstrates efficiency in turning large timber into usable firewood, a vital process for farming and homesteading life. Visitors enjoy live demonstrations where experts explain the mechanics and safety of splitting wood. It's not just a display of raw power, but also a chance to appreciate how technology has eased labor-intensive tasks. Blending tradition with utility, the log splitter exhibit at the Diebold Tractor Show embodies the spirit of practical ingenuity and the enduring strength of rural communities. The Fairbanks Morse Type Y oil engine was a heavy-duty stationary engine produced in the early 20th century, widely used in agriculture, industry, and rural power generation. Built by the Fairbanks Morse Company of Beloit, Wisconsin, the Type Y was introduced around 1914 as a reliable internal combustion engine that could run on kerosene, distillate, or crude oil, fuels more affordable than gasoline at the time.
You go to Cool Spring? Yeah. Have you seen me at Cool Spring?
Known for its durability and slow-speed operation, the engine was often used to power pumps, sawmills, generators, and farm equipment. It featured a large flywheel, hit-and-miss or throttle-governed ignition, and simple, rugged construction that allowed it to run continuously under heavy loads with minimal maintenance. The Type Y ranged in horsepower from small single-cylinder units to large multi-cylinder models. Today, surviving examples are prized by collectors and enthusiasts, representing an important step in the transition from steam power to widespread internal combustion technology. The Fairbanks Morse ZC engine was a rugged, reliable two-cylinder stationary engine produced in the early to mid-20th century. Built by Fairbanks Morse and Company, it was widely used for agricultural, industrial, and marine applications. The ZC series was an evolution of the popular Model Z line, offering higher horsepower and improved durability. Known for its simplicity and ease of maintenance, it operated on gasoline, kerosene, or distillate fuels. Farmers and small industries relied on it to power pumps, sawmills, generators, and other machinery. Today, ZC engines are prized by collectors and restorers as durable icons of early American engineering. An emergency generator driven by a Junkers-style opposed piston engine, EGA 3HK65 variant, would combine high efficiency, mechanical simplicity, and compact packaging. The opposed piston architecture places two pistons in each cylinder, moving toward each other, eliminating the need for a cylinder head or conventional valve train. Intake and exhaust ports are located at opposite ends of the cylinder, and the piston motion uncovers and covers those ports in sequence for scavenging. This design reduces heat losses and frictional losses associated with valve gear and cylinder heads. The 3HK65 designation might imply a three-cylinder layout, thus 6 pistons, or a family code, and FEMAG DGK-IO15 could be a generator set variant coupling the engine to a 15 kVA or kW alternator. In operation, the opposed piston engine runs on diesel, or similar fuel, driving the alternator via gearing or a direct mechanical linkage. Because opposed piston engines are inherently two-stroke, they deliver a power stroke every revolution per piston pair, improving power density. In an emergency power scenario, this generator would provide a reliable backup source for critical loads, e.g. communications, lighting, life safety systems. Its advantages would include compactness, relatively high thermal efficiency, fewer moving parts, no camshafts or valves, and good transient response. On the downside, engineering challenges include balancing dual crankshafts, ensuring precise timing for scavenging, managing lubrication, and mitigating emissions. If built robustly, such a generator might run unattended for many hours, especially in remote or off-grid installations. The Iran Rijeka diesel engine represents a significant contribution to marine and industrial engineering, originating from Rijeka, Croatia, a city with a long tradition in shipbuilding and heavy industry. Developed to meet the demands of large vessels and power generation, this engine has been recognized for its durability, efficiency, and adaptability across multiple applications. Rijeka has historically been a hub for advanced mechanical engineering, and the Aran diesel engine reflects the city's reputation for innovation. These engines were designed to deliver reliable power in challenging environments, particularly in marine propulsion, where efficiency and endurance are critical. Their robust construction allows them to withstand continuous operation at sea, while their engineering ensures fuel economy and reduced maintenance compared to earlier generations of diesel engines. One of the key advantages of the Aran Rijeka diesel engine lies in its versatility. Beyond marine use, it has been applied in industrial facilities, power stations, and backup energy systems. Its modular design enables customization for various output requirements, making it suitable for both large-scale commercial ships and stationary energy needs. The engines also highlight the technological expertise of Croatian manufacturing in the 20th century, standing as a product of skilled craftsmanship combined with modern engineering practices. Today, the Aran Rijeka diesel engine is remembered not only for its practical utility, but also as a symbol of regional industrial heritage, underscoring Rijeka's role in advancing maritime technology and supporting global shipping and energy industries. The Deutz MA8 711 is a robust, single-cylinder stationary diesel engine, widely recognized for its durability and reliability in agricultural and industrial applications. Manufactured by Deutz, a German company known for pioneering air-cooled diesel technology, the MAH 711 was introduced in the mid-20th century as part of the MAH series. It features air cooling, direct injection, and a slow-running design, making it highly fuel-efficient and dependable, even under continuous load. Commonly used to power generators, pumps, mills, and other stationary machinery, the MAH 711 remains popular among vintage engine enthusiasts today for its simplicity, long service life, and distinctive rhythmic exhaust sound. The Deutz MAH 711 is a classic single-cylinder diesel engine produced by KHD Deutz AG, a German manufacturer well known for durable industrial and agricultural power units. Built during the mid-20th century, the MAH series was widely used in stationary applications, small tractors, and agricultural machinery, especially where reliability and simplicity were more important than high output. The MAH 711 is an air-cooled, four-stroke diesel engine, featuring Deutz's characteristic robustness and straightforward design. Its single-cylinder layout made it easy to maintain in rural environments, where spare parts and technical support were often limited. The engine is started manually with a crank handle, reflecting its design era, and it delivers modest horsepower, usually in the range suitable for driving threshers, pumps, saws, and small vehicles. One of its strengths is fuel efficiency, combined with the ability to run reliably for long periods under constant load. The air cooling system eliminated the need for complex radiators, making it particularly valuable in agricultural and developing regions. Today, the Deutz MAH 711 is considered a vintage engine, admired by collectors and enthusiasts of historic machinery. Its simplicity, rugged construction, and distinctive diesel sound have made it a symbol of early reliable mechanization in farming and industry. An antique cement mixer engine is a fascinating piece of early industrial equipment that reflects the ingenuity of construction practices in the early to mid-20th century. Before electric motors became widely available and reliable on job sites, many cement mixers were powered by small gasoline or diesel engines. These engines were typically single-cylinder, air-cooled machines, designed for durability and ease of maintenance in tough working environments. The engine would be mounted directly to the mixer's frame, connected by belts, chains, or gears to turn the drum. Unlike modern mixers, which often use standardized electric power, antique models relied on mechanical simplicity. Their engines often featured manual cranks for starting, heavy flywheels, and exposed components, making them both rugged and noisy but dependable. Collectors and restorers today prize these antique engines because they embody a hands-on era of construction. Restoring one often involves cleaning carburetors, replacing gaskets, and carefully oiling the moving parts to bring the steady chug of the motor back to life. Beyond their practical role, antique cement mixer engines serve as historical artifacts, showcasing how builders once relied on raw mechanical power to mix concrete for roads, foundations, and buildings that, in many cases, still stand today. The Bessemer FC30HP engine is a classic example of early industrial power technology that played a major role in America's oil and gas fields during the late 19th and early 20th centuries. Built by the Bessemer Gas Engine Company of Grove City, Pennsylvania, this model represented the company's continuous refinement of stationary internal combustion engines designed for durability, reliability, and heavy-duty field work. Introduced around the early 1900s, the Bessemer FC series was designed specifically to run on natural gas, which made it highly suitable for oil field operations. The 30 horsepower rating gave it the strength to pump multiple wells, operate compressors, or drive other equipment necessary for petroleum production. At a time when steam engines were still common, Bessemer's gas engines offered operators a cleaner, safer, and more fuel-efficient alternative. Since many wells produce natural gas as a byproduct, these engines could often run directly on the gas available at the site, reducing costs and simplifying logistics.
The governor is disconnected, but the gas valve that the governor operates is half open rather than full open. And we'll give it another go.
The FC30HP was a horizontal, single-cylinder, four-cycle engine. Its heavy cast-iron frame and large flywheels provided steady power delivery, which was essential for pumping operations that demanded continuous torque. Like many engines of its class, it employed hit-and-miss or throttling governors to regulate speed depending on load. The simplicity of its design, combined with robust construction, meant that it could run for decades with only moderate maintenance. Many of these engines were operated in remote oil fields, where reliability was paramount and downtime could be extremely costly. One of the hallmarks of the Bessemer FC line was its adaptability. Though rated at 30 HP, these engines were capable of handling variable workloads and could be coupled with different pieces of equipment depending on field needs. They were frequently mounted on heavy skids, allowing them to be relocated as drilling and production shifted. Operators valued their longevity, with some engines remaining in service for over half a century. Today, the Bessemer FC30 HP engine is regarded as a piece of industrial heritage. Restored examples are preserved by collectors, museums, and historical societies dedicated to America's oil and gas history. At shows, their deep rhythmic exhaust and massive flywheels serve as reminders of a time when dependable mechanical power was the backbone of energy production.